conduit nipple is a short length of conduit, typically less than 24 inches long. The National Electrical Code, or NEC, is a set of regulations governing electrical installations in the United States. Allowable fill refers to the percentage of a conduit's cross-sectional area that can be filled with electrical conductors. The NEC defines a conduit nipple as being less than 24 inches long. The allowable fill for a conduit nipple is 60% per the NEC, which is higher than the 40% allowable fill for regular conduit. This means that for short runs, a smaller conduit nipple might be acceptable because it can accommodate more conductors relative to its size compared to a longer conduit run. This difference in allowable fill percentage is due to the shorter length of conduit nipples, which allows for better heat dissipation and reduces the risk of overheating conductors. When selecting conduit size, it's important to consider not only the number and size of conductors, but also the length of the conduit run and the applicable fill requirements. Using the appropriate size conduit ensures that the electrical system operates safely and efficiently. The NEC provides tables and guidelines for calculating conduit fill based on the type and size of conductors, as well as the type of conduit being used. These tables can be found in Chapter 9 of the NEC. To determine the appropriate conduit size, firstly, identify the type and size of conductors to be installed. Secondly, determine the allowable fill percentage for the type of conduit being used, whether it's a nipple or standard conduit. Thirdly, calculate the total cross-sectional area of all conductors. Fourthly, refer to the NEC tables to determine the minimum conduit size that meets the allowable fill requirements. It is important to remember that exceeding the allowable fill percentage can lead to overheating of conductors, which can damage insulation and potentially cause a fire. Therefore, it's crucial to follow the NEC guidelines and ensure that the conduit is properly sized for the intended application. There are several types of conduit commonly used in electrical installations, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and rigid polyvinyl chloride conduit. Each type of conduit has its own advantages and disadvantages depending on the application. Rigid metal conduit, or RMC, is a heavy-duty conduit that provides excellent protection for conductors. It is typically used in outdoor or industrial applications where the conduit is exposed to physical damage or corrosive environments. Intermediate metal conduit, or IMC, is a lighter weight version of RMC. It offers similar protection but is easier to work with. Electrical metallic tubing, or AMT, is a thin-walled conduit that is commonly used in indoor applications. It is lightweight and easy to bend, making it a popular choice for residential and commercial wiring. Flexible metal conduit, or FMC, is a flexible conduit that is used in applications where the conduit needs to be bent or routed around obstacles. It is commonly used to connect motors or other equipment that vibrates. Rigid polyvinyl chloride conduit, or PVC, is a non-metallic conduit that is resistant to corrosion. It is commonly used in underground or wet locations. When selecting the appropriate type of conduit, consider the environmental conditions, the type of conductors being installed, and the applicable code requirements. It is also important to ensure that the conduit is properly supported and secured to prevent damage. Conduit bodies are used to provide access to conductors inside a conduit run for splicing, pulling, or making taps. They are available in various shapes and sizes, including LB, LL, LR, and T configurations. Conduit bodies are typically made of metal or plastic and are designed to be weatherproof or watertight, depending on the application. When installing conduit bodies, ensure that they are properly sized for the conductors being installed and that they are securely fastened to the conduit. It is also important to seal the conduit body to prevent moisture from entering. Pull boxes are larger enclosures that are used to facilitate the pulling of conductors through long conduit runs or around multiple bends. They provide a convenient location to stop and pull conductors, reducing the pulling tension and making the job easier. Pull boxes are typically made of metal or plastic and are available in various sizes, depending on the application. When selecting a pull box, consider the number and size of conductors being installed, as well as the length and number of bends in the conduit run. It is also important to ensure that the pull box is accessible and that it meets the applicable code requirements. Conduit fittings are used to connect conduit sections together or to connect conduit to boxes or equipment. They are available in various types, including couplings, connectors, elbows, and lockouts. Conduit fittings are typically made of metal or plastic and are designed to provide a secure and watertight connection. When installing conduit fittings, ensure that they are properly tightened to prevent loosening or leakage. It is also important to use the correct type of fitting for the type of conduit being used. Grounding is an essential part of any electrical system. It provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Conduit can be used as a grounding conductor, provided that it meets the applicable code requirements. When using conduit as a grounding conductor, ensure that all conduit sections and fittings are properly bonded together to provide a continuous electrical path. It is also important to connect the conduit to the grounding electrode system, which is typically a ground rod or a metal water pipe. The National Electrical Code, in Article 300.14, requires that at least 6 inches of free conductor be left at each outlet, junction, and switch point for making connections or splices. This requirement applies to all types of wiring methods, including conduit. The purpose of this requirement is to provide enough conductor length to safely and easily make connections or splices without straining the conductors or the connections. It also allows for future modifications or repairs to the electrical system. When installing conductors in conduit, ensure that you leave at least 6 inches of free conductor at each termination point. This will make the wiring job easier and safer, and it will also comply with the National Electrical Code. The National Electrical Code, in Section 314.16, specifies the requirements for box fill calculations. Box fill refers to the maximum number of conductors, devices, and fittings that can be installed in an electrical box. The purpose of box fill calculations is to prevent overcrowding of the box, which can lead to overheating of conductors, damage to insulation, and potential fire hazards. To calculate box fill, firstly determine the volume of the box in cubic inches. Secondly, determine the volume allowance for each conductor, device, and fitting in the box according to the NEC tables. Thirdly, add up the volume allowances for all items in the box. Fourthly, compare the total volume allowance to the volume of the box. The total volume allowance must not exceed the volume of the box. The NEC provides detailed tables and examples for calculating box fill, which can be found in Section 314.16 of the Code. It is important to follow these guidelines carefully to ensure that the electrical system is safe and compliant. Conduit bending is a skill that is essential for electricians and electrical contractors. It involves using specialized tools and techniques to bend conduit to specific angles and shapes, allowing it to be routed around obstacles and through tight spaces. There are several types of conduit benders available, including hand benders, hydraulic benders, and electric benders. Each type of bender has its own advantages and disadvantages depending on the size and type of conduit being bent. When bending conduit, it is important to follow the manufacturer's instructions and to use the correct bending techniques. It is also important to avoid kinking or damaging the conduit, as this can weaken it and make it difficult to pull conductors through. The NEC, in Section 344.30, specifies the requirements for supporting and securing rigid metal conduit, or RMC. RMC must be supported at intervals not exceeding 10 feet. This means that every 10 feet of RMC must be securely fastened to a structural member or other suitable support. The purpose of this requirement is to prevent the conduit from sagging or shifting, which can put stress on the conductors and connections. The NEC also specifies the types of supports that are permitted for RMC, including straps, clamps, and hangers. These supports must be designed to securely hold the conduit in place and to prevent it from coming loose. When installing RMC, ensure that it is properly supported and secured according to the NEC requirements. This will help to ensure that the electrical system is safe and reliable. The NEC, in Section 358.30, specifies the requirements for supporting and securing electrical metallic tubing, or IMT. EMT must be supported at intervals not exceeding 10 feet. This is the same requirement as for RMC. However, EMT is a thinner and lighter material than RMC, so it is important to use the correct type of supports to prevent it from bending or collapsing. The NEC also specifies the types of supports that are permitted for EMT, including straps, clamps, and hangers. These supports must be designed to securely hold the conduit in place and to prevent it from coming loose. In addition to the 10-foot support requirement, the NEC also requires that EMT be supported within 3 feet of each box, fitting, or termination point. This helps to prevent the conduit from pulling away from the box or fitting, which can damage the conductors and connections. When installing EMT, ensure that it is properly supported and secured according to the NEC requirements. This will help to ensure that the electrical system is safe and reliable. The NEC in section 352.30 specifies the requirements for supporting and securing rigid polyvinyl chloride conduit, or PVC. PVC conduit must be supported at intervals not exceeding 3 feet for a 1/2 inch and 3/4 inch conduit, 5 feet for a 1 inch, 1/4 inch and 1/2 inch conduit, 6 feet for 2 inch and 2/2 inch conduit, and 7 feet for 3 inch conduit and larger. These support requirements are more stringent than those for RMC and EMT because PVC is a more flexible material and is more likely to sag or shift if not properly supported. The NEC also specifies the types of supports that are permitted for PVC conduit, including straps, clamps, and hangers. These supports must be designed to securely hold the conduit in place and to prevent it from coming loose. In addition to the support requirements, the NEC also requires that PVC conduit be installed in accordance with the manufacturer's instructions. This includes using the correct type of fittings and adhesives, and following the proper procedures for cutting and joining the conduit. When installing PVC conduit, ensure that it is properly supported and secured according to the NEC requirements and the manufacturer's instructions. This will help to ensure that the electrical system is safe and reliable. The NEC in Article 310 provides detailed tables and guidelines for determining the allowable ampacity of conductors. Ampacity is the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. The allowable ampacity of a conductor depends on several factors, including the size and type of conductor, the insulation type, the ambient temperature, and the number of conductors in a raceway or cable. The NEC tables provide ampacity ratings for various types of conductors under different conditions. It is important to consult these tables carefully when selecting conductors for an electrical installation to ensure that they are properly sized for the intended load. The NEC also provides rating factors that must be applied when conductors are installed in certain conditions, such as when they are installed in a hot environment or when there are multiple conductors in a raceway. These rating factors reduce the allowable ampacity of the conductors to prevent them from overheating. When selecting conductors for an electrical installation, it is important to consider all of the applicable factors and to consult the NEC tables and guidelines to ensure that the conductors are properly sized and rated. This will help to ensure that the electrical system is safe and reliable. The NEC in section 300.11 specifies the requirements for securing and supporting wiring and equipment to building structures. This section of the code is intended to ensure that wiring and equipment are properly installed and supported to prevent them from becoming damaged or creating a safety hazard. The NEC requires that wiring and equipment be securely fastened to the building structure using approved methods such as screws, bolts, or clamps. The wiring and equipment must also be supported at intervals that are sufficient to prevent them from sagging or shifting. The NEC also prohibits the use of building structural members, such as pipes or ducts, for the support of wiring or equipment, unless specifically permitted by the code. This is to prevent the structural members from being damaged or overloaded, which could create a safety hazard. When installing wiring and equipment, it is important to follow the NEC requirements for securing and supporting them to the building structure. This will help to ensure that the electrical system is safe and reliable. The NEC in section 300.4 specifies the requirements for protecting wiring from physical damage. This section of the code is intended to ensure that wiring is protected from damage caused by nails, screws, or other objects that could penetrate the wiring insulation and create a safety hazard. The NEC requires that wiring be installed in a manner that protects it from physical damage. This can be accomplished by installing the wiring in conduit, tubing, or cable armor, or by locating the wiring in a protected area where it is not likely to be damaged. The NEC also requires that wiring be protected from abrasion or sharp edges that could damage the insulation. This can be accomplished by using bushings or grommets to protect the wiring where it passes through holes in metal or other materials. When installing wiring, it is important to follow the NEC requirements for protecting it from physical damage. This will help to ensure that the electrical system is safe and reliable. The NEC in section 110.14 specifies the requirements for making electrical connections. This section of the code is intended to ensure that electrical connections are made properly to prevent overheating, arcing, or other hazards. The NEC requires that electrical connections be made using approved methods such as wire connectors, soldering, or welding. The connections must be tight and secure to ensure that there is good electrical contact between the conductors. The NEC also requires that electrical connections be insulated to prevent short circuits or ground faults. The insulation must be suitable for the voltage and temperature of the circuit. When making electrical connections, it is important to follow the NEC requirements to ensure that the connections are safe and reliable. This will help to prevent electrical hazards and ensure that the electrical system operates properly. The NEC in section 250.8 specifies the requirements for making connections to grounding electrodes. Grounding electrodes are used to provide a low impedance path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC requires that connections to grounding electrodes be made using approved methods such as exothermic welding, listed pressure connectors, or listed clamps. The connections must be tight and secure to ensure that there is good electrical contact between the grounding electrode and the grounding conductor. The NEC also requires that grounding electrode conductors be protected from physical damage. This can be accomplished by installing the conductors in conduit or by locating them in a protected area. When making connections to grounding electrodes, it is important to follow the NEC requirements to ensure that the grounding system is effective and reliable. This will help to protect people and equipment from electrical shock. The NEC in section 250.64 specifies the requirements for grounding electrode conductors. Grounding electrode conductors are used to connect the grounding electrode to the electrical system. The NEC requires that grounding electrode conductors be sized according to the size of the service entrance conductors. The NEC also requires that grounding electrode conductors be made of copper or other corrosion-resistant material. The conductors must be continuous and unbroken from the grounding electrode to the electrical system. When installing grounding electrode conductors, it is important to follow the NEC requirements to ensure that the grounding system is effective and reliable. This will help to protect people and equipment from electrical shock. The NEC in section 250.50 specifies the requirements for grounding electrode systems. A grounding electrode system is a combination of grounding electrodes that are used to provide a low impedance path for fault current to flow back to the source. The NEC requires that all electrical systems be grounded using a grounding electrode system. The grounding electrode system must consist of one or more of the following electrodes: a metal underground water pipe, a metal frame of the building, a concrete encased electrode, or a ground ring. The NEC also specifies the requirements for the size and installation of each type of grounding electrode. When designing and installing a grounding electrode system, it is important to follow the NEC requirements to ensure that the grounding system is effective and reliable. This will help to protect people and equipment from electrical shock. The NEC in section 250.96 specifies the requirements for bonding metal enclosures. Bonding is the process of connecting metal enclosures together to create a low impedance path for fault current to flow back to the source. The NEC requires that all metal enclosures that are likely to become energized be bonded together. This includes metal conduit, metal boxes, metal cabinets, and metal equipment. The NEC also specifies the requirements for the size and installation of bonding jumpers. Bonding jumpers are used to connect metal enclosures together. When bonding metal enclosures, it is important to follow the NEC requirements to ensure that the bonding system is effective and reliable. This will help to protect people and equipment from electrical shock. The NEC in Article 430 provides detailed requirements for motor circuits. These requirements cover everything from the sizing of conductors and overcurrent protection to the installation of motor controllers and disconnects. The NEC requires that motor circuits be designed and installed in accordance with the specific requirements of Article 430. This is to ensure that motor circuits are safe and reliable and that they do not create a fire or shock hazard. When designing and installing motor circuits, it is important to consult Article 430 of the NEC and to follow all of the applicable requirements. This will help to ensure that the motor circuit is safe and reliable. The NEC in Article 440 provides detailed requirements for air conditioning and refrigeration equipment. These requirements cover everything from the sizing of conductors and overcurrent protection to the installation of disconnects and safety controls. The NEC requires that air conditioning and refrigeration equipment be designed and installed in accordance with the specific requirements of Article 440. This is to ensure that the equipment is safe and reliable and that it does not create a fire or shock hazard. When designing and installing air conditioning and refrigeration equipment, it is important to consult Article 440 of the NEC and to follow all of the applicable requirements. This will help to ensure that the equipment is safe and reliable. The NEC in Article 517 provides detailed requirements for healthcare facilities. These requirements cover everything from the wiring of patient care areas to the installation of emergency power systems. The NEC requires that healthcare facilities be designed and installed in accordance with the specific requirements of Article 517. This is to ensure that the electrical systems in healthcare facilities are safe and reliable and that they do not create a fire or shock hazard for patients or staff. When designing and installing electrical systems in healthcare facilities, it is important to consult Article 517 of the NEC and to follow all of the applicable requirements. This will help to ensure that the electrical systems are safe and reliable.